right, I think we can make this a short one. Just wanted to run through for anybody that did the 6.2 and 3 review worksheet so they could see the solutions. Again, pause where needed. Obviously, you can see that the quiz is attached to this assignment, so I wrote in the directions. It's written on the quiz. You get a single shot with it. It doesn't save your answers anytime through, so just kind of plan on sitting and doing it in a 20-minute window or whatever, and you should be good. It covers the same concepts we're covering here that you did on the homework, so I think we should be all right. It's basically a point-to problem, kind of all right or all wrong type of thing. Just pay attention to how it's asking you to input your answers. You know, there's a few that say, like, don't write any spaces or whatever, because it's going to kind of automatically grade them or whatever. And I'll go back through and look just to make sure that there's not anything that's like, oh, it's screwed up or whatever. But just pay attention to how it's asking you to input your answers. Most of them is just a single answer. There's a lot of multiple choice, but there are a few that you're actually typing out that it's going to check. So just pay attention to that. All right, here we go. Evaluate the logs. I realized there was a few that were kind of overlapped. I think this one might have been on one of the homework, which is fine. It doesn't matter. It's really just kind of getting that practice, changing forms, and evaluating. So kind of just going through. You've got yours there. Graphing. So remember, two types of graphs we did. This is the first type, graph with an E base, a decay function right there by the negative, a growth right here. This one was a little bit unique in that from -2 to 2, you really only got this really short kind of from here to here, which wasn't a great graph. So you can kind of tell by my table here, I ended up going quite a bit further out in each directions. The reason is it's a very flat, this 0.2 is, the closer this gets to 0, the flatter the graph is going to be, at least initially. So I just went out a few more places to give me a better shape on the graph. This one was kind of the opposite way, where really from, I kind of just started at 0, but by the time I got to 2, we were way off the graph. And then same thing kind of going the other way. By the time I really hit -1, -2, we were down to nothing. So yeah, so we have there. So this is actually the first thing that we worked with in the lesson. You can kind of see something happened here. I whited it out. But just working with E, you know, it's the same, those properties of exponents and roots and radicals. So breaking, you know, here's an example of breaking 48 up into perfect cubes because it's a cube root function, and then keeping what we can keep under the radical. And so that's what we got working with E. The back here is mainly, I think, all logarithmic stuff. So going the other direction now, changing logs back to exponential, and then going from exponential to log. So just watch stuff like that, you know, where you have E base, we write it with a natural log. If there was a common base, which we see here, remember, we wouldn't write that. If this was the original and I said, hey, write this right here in logarithmic form, we would take that 10 out of there and just write log 1000 equals 3. So little stuff like that. The inverse, remember a couple different steps. I'm numbering like I did on the homework, or as we talked through them in the notes. Rewrite it 3/4 to the y power equals x. Okay, and then just swap your x and your y. I left them with the y on the right side today, it doesn't matter. Change forms, so I need log base 3. Remember, how does this work? 3 to the x power equals y. Okay, that's what this says. Change forms, and then switch your x and your y. I think the last one here, probably the toughest. We've seen something like this. Add your base, so you can see it. This is just y over here, remember. E to the y power equals this whole thing. Right, that's just how that works. Swap your x and your y, so now e to the x equals y plus 2, and then the last step is get everything, or get the y by itself, so bring that 2 over. Okay. Graphing still involves that ability to rewrite. Okay, so 3 to the y power equals x. Pick values of y and see what you get for x. Right, 3 to the 0 power is 1. 3 to the first power is 3. So you're plugging this number in first, getting this number, but then we're still graphing it as if, you know, 1, 2, 3, 1. There's 3, 1. There's 9, 2. Okay, you still plot it as an x, y. For whatever reason, I just like a vertical table here, so totally up to you. Same thing going on here, just with a number between 0 and 2 for the base, or I'm sorry, 0 and 1 for the base. That's just how it's gonna work out. 1/2 to the y power equals x. So same thing as before, pick y values and then plot them. 0.1253 would be up here, 0.252. So it's just plot them as normal and your graph should show up how it shows up. Domain and range I didn't mention on the front, but it's just look at your graph. How far left does this graph go? Remember, it's left, right, bottom, top. So left, not quite 0, that's why we're not including it. Parenthesis, right forever, down forever, up forever. Okay, left, we're stopping here. We got an asymptote at 0, so left to 0, right to infinity, down forever. It's going to go down forever, and then up forever. Okay, so that was our domain and range. So there you go. There's your review worksheet. Get that quiz done. I'll give you till Tuesday night. We might start some new notes hopefully early next week, Monday or Tuesday, but that still gives you time till Tuesday. I set the date for on the quiz. So get it done, get it submitted. I'm still working on that IC update, so just bear with me. If you're taking care of your stuff and doing the assignments and submitting them, you're doing fine. Nobody should have any worries unless you're not doing that stuff. So, all right, that's all I got. Have a great weekend. I will talk to you again next week.